You have anything to ask me？ 这个星期好像是比较特别没有听说吗？为啥？你们听说了这个星期有什么特别的事儿发生了吗？
没有。
Nothing special this week?
哦，我们今天特别神奇的是，线性代数课居然讲格拉斯曼流形。
这个不算什么奇怪的。
当然算奇怪了。
啊，你们没看新闻，数学新闻也没看，没看数学新闻，没时间。
我看了一点那个YMSCC 的网站，看他们有很多会议。
那上面写的是什么呢？
有好多会议。
哦，会议，可是没有看到数学新闻啊。是你们知道这个 Kakeya conjecture？
哦，知道。哦，听说有人解决，听说有人解决了，但是它的具体内容。
这是关于代数 ，Is that about algebraic?
No. 是analysis, right? Factor sets.
Oh yes, yes.
听说了吗？没有听说。这个被一个叫王红，应该是王红和红写错了，王红，然后是Joshua Tsai 发表了在25号，2月25号，这是这个星期发表的一个文章，然后这 Terry Tao 是说这个是对的啊。OK， 你们可以去查一下到底是什么，就是然后至少邱先生说他王红肯定是得个 Fields Medal， 因为这个是个很重要的一个 conjecture。OK， 所以说做数学的话呢，还是得多观察一下新闻。
塔克亚开讲我好像也看到过。
是什么？说的是什么呢？
我看到过一个截屏，看到过一个截屏。我是问的截屏看到过。
你们知道这是什么？这猜想是做什么？它是什么 conjecture 吗 ？What is the conjecture？ 你们知道吗
Unsolve the math problem.
Yeah. Do you know what it's about? No. Okay. It's about 至少跟你们说一下这是什么意思嘛 Kakeya sets. OK. 然后这个说的是这个东西有多大啊？这个 Kakeya set 是什么东西呢？就是 for every direction. So let's call it A. Theta in or wait a sec. 写错了。这个 set 是在一个 Rn 里面啊，很简单。n 有3的话就在我们的 space 里。然后呢 ，for every direction, theta or theta in Sn， 就是这个 n 维里面的球啊，球面就是有，just it means its direction, okay? There exists a line of length 1, so non-trivial means contained in that direction, or line segment of direction theta contained in A. Okay? 所以说，如果 if you have a plane, okay, how does such a set look like? If I look in this direction, then I know somewhere on the line, this piece here is in my set A. And that's for every direction I look into. So, but then a set can look very weird. You can look this way and this way. So the question is, if I go around one time, how much volume does the set contain?
Oh, okay.
So the general conjecture is, well, the so-called Hausdorff dimension should be n. Okay. What is the Hausdorff dimension?
That's, for example, you cut it by for each coordinate you cut it by MPCs, and you just cut all of it
Yeah.
n pieces, then the whole dimension is divided by log log m.
If that's a set, yes. If it's possible to cut it into these pieces, yes. So the Hausdorff dimension, so normally it's just a dimension. So for the plane, it's 2. For our space, it's 3, and so on, right? For the line, it's 1. Now, it is known that such a set, a Kaikeya set, can have measure 0, meaning these things are so,
Volume 0.
yes.
Volume 0.
Although you go around completely, yeah? You go around completely, this thing can have measure 0. Nevertheless, the Hausdorff dimension is always 2, okay? Okay, so that's in R2. Okay, that's in R2, and this is proven. And this paper solved the conjecture in R3. Okay, that's all the conjecture is about. Okay, so it was an open conjecture for whatever 30 years. Many people worked on it, and it's still open for any n greater equals 4. Okay, so the question is how complex, how difficult can this set be when you go around and you have these lines everywhere in every direction? How complex can such a set look like? Right? The easiest one maybe is just a disk, right? Of course, the disk has dimension 2, right? You can see it, it's dimension 2. Now, when we go slightly more complicated, or like this, you can have topology. It's still dimension 2, right? There's nothing changed. Okay? Now the question is how to construct something so that the measure, so the measure is 2 as well. I mean, 2-dimensional measure is non-zero. Okay? So it has an area, right? You can compute the area. But you can do the red lines in a way so that kind of like this maybe. Okay? And then rotating in a more slightly like this way, so that the measure, when you rotate once, never cover something with area. The area is 0. Okay? So it's possible. It's a weird thing. Okay? It's very weird, because that means for every direction, you have to pin it in a way that it doesn't connect to each other properly. Yeah? But nevertheless, the Hausdorff dimension, so the measure that measures the complexity, is still 2. Okay? So that's a conjecture, and it was just recently solved in R3. So that's the huge news this week in math world, okay, for math researchers. Well, you can try to solve. If you have something for n greater equals 4, it earns you a Fields medal. Okay, so it's still open for any dimension greater equals 4. Okay. So this was big news this week. So if you want, you should stay informed about what's happening in our world. Okay. That's why I think it's a funny thing to do. Okay. The other thing I would like to do are projects. I'm pretty sure you know some of this. Huh?
Projection?
No, just project with you. I want you to do some projects independently, and I would like you to do that after the class or, meantime, okay? Okay, but maybe the project I chose, you know already, but then we need to find something else, okay? The first thing I have in mind is something very classical, classification of Platonic solids. You know what these are?
Yeah.
Yeah? What are these? Yeah, so you have a polyhedron, okay? For example, a tetrahedron, which consists, every face is a regular n-gon. In this case, every face is a triangle. And then you have a cube.
There are only 5 ones.
5.
Yeah.
Oh, by the way, my best friend,
And then I cannot draw them anymore.
School just prove it.
Yeah, you can. I mean, it's quite easy to prove, right? But don't cheat. Yeah, you prove it yourself. Don't look it up. Don't look it up. The point about this exercise is to do it yourself. Okay, that's one.
I think that's actually this exercise in the book written by Amy Armstrong and Basic Topology.
Maybe, yeah. It's an easy proof. It's a very nice one. The question is, what are the more important one is what are the assumptions? Okay, to have the 5. Okay. The second one is what is a Möbius strip. Okay, and then if you do the Möbius strip, can you do can you do a Möbius strip with the paper? Yeah, just do it with the paper. Yeah, do it with the paper. Okay, with a piece of paper. Okay, and then you glue it together. Okay, you glue it together, and then I want you to take a scissor and then cut through the Möbius strip in the middle, and then I want you to explain what happens.
This is a Möbius strip, and this is not yes, like this.
Yes, but then 把它
莫比乌斯环。
对，做一个把贴到一起，然后你从这中间切开，剪开 ，and then tell me what happens. Yeah, and then tell me what happens. 太窄了，不好切。Okay, and then explain me what happens. 用剪刀从中间剪，对，从中间 like this, in the middle like this. Okay. You have to glue it together first, otherwise it doesn't work.
And it's actually an unorientable metaphor with error.
You should well, unorientable is not true, and if you cut it, I mean.
Not be oriented.
If you cut it, if you glue it together and then cut it in the middle, I want you to explain me what happens, okay? And why it happens and what the result is. Okay?你们得先贴起来，然后再。What? You don't have glue? You don't have?
一个孔啊，然后出个孔，还得外包起来，不就得了？
Do you have glue? Oh, you. Oh.
Like you roll it and then it comes.
Okay. Can you do it? Just glue it together first. Here, she has glue for you guys.
Oh,
A little bit.
Oh, that's a kind of good.
Don't do everything, yeah? Which can happen, just out of experience. Okay, so if you glue it together, then you cut it in the middle like this, around.
涂2下或者3下。
Okay, it should be enough. Don't use every. Oh, well, don't. I mean, it just should hold, and that's all. Okay, good. A little bit, it's enough. Yeah. I owe you one. Okay. Good.
Can we do like this?
Do it. Cut it in the middle.
Okay.
Okay, cut it here.
I mean, can we do like this?
Yes, you can do it. Okay, and the point is explain me the result and what would be the difference if you do it with a cylinder. Okay. Oh, they have. Okay. Did they return your thing to you? Your glue?
Okay.
Okay.
Make a bigger one.
Is it a Möbius strip though? Okay. Okay, so this is a project, yeah? I'm asking, you do the Möbius strip, you cut it.
There are three twists, but you can just cancel one of them.
Okay? And explain me the result and why this is the result, okay? The third is geometry on S2 and the hyperbolic space H2, okay? So what is the difference between what we do here and what is in the geometry here, okay? So these are 3 projects you can think about, and then the idea would be that you present the results next time to your class. Okay? Huh? What is the result? 还是一个 Möbius band 吗？
然后我手撕完之后，我感觉像3条完。好像是3条完。
Think about it. Try to color one side of that one.
我这个做出来是那个转身。
你画一根线在上面，最简单的是。You still don't have the scissors? Can you give her 给她一个？
那就转2次。
转2次是这样的。你再剪辑我分开了。
我现在还是不是一个圆圈。不是一个圆圈的。
So is it still a Möbius band or not?
黑一个。
No.
这是你画啥？
And then now I.
转1个。
So I click. So you need to explain me why. What happened? Okay. Okay. By the way, instead of the middle, you can cut by a third, and then you see what happens then. Yeah. 也可以。你们切的时候可以有2种啊，切一个是这样子切成1半儿，一个是1/3。You can try. You will still see. You can try that. It's actually very fun. Okay.
你刚刚说那个扯开之后的那个。
扯开之后我弄太细了。
不是你没有看懂啊。
我天，不是，你说1/3呢？2下。我也喜欢。不是，你不跟着上课，就在吵上去。不是他最后说不拿
点1/3太冷了，这个胶太轻。
所以说，能借条
胶在他那里。
能也借我一下胶吗？行，今儿就拿，今儿就拿。
Okay.
长得说申请兵吧啊。
的确非常帅。
Continue. Yeah, continue. It's fine. All good. Just continue till it stops.
老师最后他是应该是得转2圈。
Not. Yes, continue. So what is it? 这是什么？
不知道啊，老师，我撕了2遍。
你好像这好像是4分之一。
对，老师，我撕了2遍。
对，肯定是吃了2遍。可是这个好像，那你看看这是什么东西呢？你每一个是一个 Möbius 板还是有一面的？
老师不知道啊，我把它描一遍吧。
对呀，那你知道怎么检查这个吗？
哎，怎么套进去
就是套一个
你这个好像也是不是1/3，这是1/4剪的。
然后我就把4/4剪。
4/4剪能套3个
拿
吗
1/3剪。
不是，这肯定不是1/3剪的，剪错了。他剪的是米娅剪的对的。
Then it will twist 2 times.
Which one will twist 2 times?
The half. This is the line and this is the normal vector.
Yes.
It is flipped and flipped again.
Yeah. So this is
it's
twice. Yes. And what about the middle part?
然后一个环和一个环，然后一个环和一个我们不是在。
一个环。
然后这边呢？
好问题。
老师就是一个环和一个。
这也是个环。我看啊，你看就因为你这剪的是1/4，剪的就剪的多了。它这个也是对的，一个是 Möbius band， 一个是环。
一个还是我，一个实际上一个环。
Look at this。
那为什么我做的跟
因为你
稍大这个是
多转了一圈。
稍大这个是环。
你把这个也重新再剪了一次。对。
大那个是。
OK。
那个还能继续剪。
对，因为你小这个又剪了一次的原因。
不是，我是直接撕了。
Okay.
我是撕了一半之后再。
So now, the question is why? Yeah, it's fun, right? It's funny that it happens. Now the question is why, and why also they are linked, right? They're in.
不是你不会手撕吗？
手
就是用手撕的。
现在所以就出错了呗。
剪了3遍。
老师，如果我把它细分为无穷份会怎么样？我把它细分为无穷份。
会做无穷的跟那个转2圈的环套起来。
对他们就这样子的，对。
我剪了3条。
老师，你看我这玩意儿，我也想剪个10条试试。
可以啊。
截成8次这个玩意儿。
你要看可以。是这样子剪，可以剪成什么？对，那为什么套到一块儿呢？
我现在想，哎，不是这个小的，一看就是我们。
对。
然后我这是2个环套在一块。
对，因为然后你那这个你可以看看是。
都是环。
对，然后是还很奇怪的套到一块儿呢。
老七，我觉得拿橡皮筋儿更好。
我选择再借一下胶。
你能撕橡皮筋啊？
谢谢。
可以啊。
这怎么那么奇怪
？So you can think about why, OK?
不是我这剪的太奇怪。
1/3吗？
完了，我剪完之后才发现是班老师的问题。
不错，姐姐把数学作业给剪了。把自己的数学作业给剪了。
好吧。
你看这是
对，再做一次了。Okay, so you can discuss later why this is the case and what concept you can developed from here. So what does it actually mean? What is the difference, okay, between a cylinder, a strip? Like, what is the difference between these two strips? Okay? Is still something left?
Yeah.
It's all good. I buy you a new one.
Okay.
我要做一个环面。哇，剪这么好
I,
剪。
I buy you. I buy a new one for the next time. Okay. I didn't expect them not to have glue here, to be very honest. Okay. Okay. So that's just for fun, yeah? We can, so if you want, you can explain it to the others next time, okay? And then, till then, you can think about why this is the case, okay? What happens and why is this the case? Okay? Good. So, can we move on?
Yes.
Good. Who can tell me what we have done last time?
We just have some basic definition and
Wait a sec. You should start.
嗯，
You start. What happened? 我们上次做了什么？
好问题。
我们上次你有病啊？
忘了吗？都忘了。
我这那个
Basic
point
definition of
啊？
就是 ray，
and
Ray. Okay. What is a ray?
is past access.
Mm-hmm. What do you still know? Just out of the head. 就不需要看啊，就跟我说一下，你们还知道什么 ？Keywords is fine. Some words. 知道什么
Line segment.
？Segments.
And actually,
Line. Right. What else?
Euclidean.
Euclidean. What else?
and S2H2
Well,
a little bit.
tiny bit. Don't count. It doesn't count. What else?
Some axis.
Axioms, exactly. Right? We did axioms. What we didn't do is what can we do with axioms? We just had axioms. Okay, very tiny little bit. Okay? What kind of, let me say what axiom we had. Okay? Just to repeat. We had incidence axioms, which means intersection in ancient words. It said 2 points, distinct points, uniquely determines the line. Second, what else? Every line contains at least 2 points. And we need a plane, so it exists 3 points,
Not in a line.
not on the line. Okay? This gives us that there exists at least a plane. Okay? That's the point. We have a line, which is one-dimensional geometry if you want, and exists at least a plane, so we can draw some pictures. Otherwise, it's slightly boring. Okay, that's incidence. The second one we had, so that's the first, is order. Meaning, we wanted to define what it means for a point to lie between two other points. Okay? We don't say what it is, we just say exists something like that. Okay? then only one of the three can be true for 3 points. BC, AC, and C in AB. So it cannot be, if I have 3 points, I can only have one particular order, not multiple. That's what this says, okay? And when I have 2 points, I can always surpass the middle one to get to the third one, okay? And then we had Pasch, which was when I have a triangle and a line. If the line goes into the triangle, it must go out of the triangle again. 2 intersection points, okay? You can also go this way. So if it goes in, then there's another line where it goes out, okay? So now the question is, what is the use of this axiom? That was the homework, kind of, right? Why do we need such an axiom? So this just gives me that if I have 3 points, then I have an order, 一个顺序, okay, a fixed one, okay? That's why these are called order axioms. Now, Pasch axiom is slightly different. It says a line intersects the triangle at one point, goes to intersect the triangle at the second point on the other line. Why do we need that? Any ideas? So let me give you some exercises for these. Maybe it's clearer after the exercises why you would need these kind of axioms, right? Because it's kind of, I should say, Hilbert didn't know about the Pasch axiom. So he had this other axiom, which was redundant, okay? And then Pasch came and said, well, this one is really important, okay? So it's had some, okay. So let us do some exercises so that you actually practice these things instead of forgetting it again. So first of all, find a plane so meaning only with the first set of axioms here with 4 points and 6 lines. If you have a ray from A to B, meaning I start here, look into this direction, okay? How to define it, maybe that's the first thing, but if I have a ray from D to A, so in this direction, then intersection of these 2 rays is exactly the segment AB, okay? So this gives me, so basically for the rays and so on, you need to define what it means to be on one side of a point and what it means to be on the other side of the point, okay? Three, define a half plane. What could that be? Okay, so intuitively, it's just a line, and I have a point A, then all the points on this side should be define my half plane, right? Yeah. Bounded by the line. But then how to do that using the axioms, not just visually, because we don't have that it's a plane yet, right? We don't have R2 yet, okay? And then show every line bound exactly exactly 2 half planes. And there's no intersection point if I don't define a half plane with a line. Yeah. Section. Okay. By the way, what it means after we have all this is that now we have points, okay, and we have a ruler. We can draw straight lines, okay, in any direction, but there's no digits on the line. So we cannot measure yet how far 2 points are. We don't have a distance, but we have a ruler. We can say it's in between or outside.
Straight edge. Straight edge.
Yeah. So that's what we have to play with. So we don't have the thing you have with measurements. We just have some device that helps us to draw straight lines. Okay. Maybe 5 minutes. Think about it. And then you can discuss with your neighbor how this should work. If you don't know anything how to go, ask me. Okay, that's the idea is that you can do it yourself in a sense if you can, because that's how you learn. But if you don't know, then ask me. Yes. Oh, that one you have to. So the idea of the incidence plane is that it's a set of points, right? Okay, it's a set of points only. And the line is not necessarily a line you see we draw, right? We had this example last time where the simplest was just 3 points. And it has 3 lines because these 2, we say it's a line, although it doesn't look like a line. These 2 we call a line, and these 2 called a line. So between every 2 points, we have now a line. And all these things works. It's just 3 points that makes a plane, which is they don't lie all on the line, right? We have every line contain at least 2 points, exactly 2 points. And so this makes a plane. On that, it consists only of these 3 points.
I've done all of them.
Okay, perfect. Wait a sec. The others need to do this. Now, the question is, so this configuration here has 3 points and 1, 2, 3 lines, right? Now the question is, how can we do it with 4 points and 6 lines? No. Give the others a chance to think about it as well, okay? You can show it to me, but yeah. So you think about such a configuration where you have 1 point more, but a lot of lines more, okay? Where are the 4 points and 4 points? Let me see.
These are the 4 points. 2, 1, and...
Mm-hmm. Okay, good. That should work.
Second one,
is like this, and by this the order axiom the third, so that it's easy to know that RAB is like that RBA equals only this part should be true, so it should be AB.
So you take all the C's which lies in AB, that's fine.
Or A lies in CB.
Well, that should be the ray from B to A, so other way around, but right?
Okay, that's
Other way around, but yeah, exactly. Now the question is, why is the intersection of these two AB? How to show it properly?
The second one is like this because there is axis.
Give the other two.
Hence that the intersection means that A is in CB or C is
Yes.
in AB, but while A is in BC.
Write it down. Write it down as a proper proof. 可以。
第二题的话就是把它写成几何形式，然后取个交集是吧？就是取这个。
对，这里先一个 definition， 先定义是什么？
对，因为现在定义了嘛，就是可以定义它这个和延长线吧。
你写下来，给我看看。
Okay.
写下来写下来也很重要。So, and then what are the lines?
Here, and this, and this, and this.
Yeah, you can yes, perfect. Yeah, it works. Right? You can connect the points to see the lines, right? It's easier to count. Perfect. Okay. Okay. As important as the idea is to write it down properly. Okay.
It means the third one maybe is y is more than x. It is in the R2.
What do you mean by bigger?
I mean it is like in R2 it means y x. That's y. That's bigger than x maybe.
Yeah, but what is the line? The line is arbitrary. Yeah. Is it? I didn't fix a line.
Oh yeah.
I didn't fix a line. How to define? Anything. And you should do it with the axioms, and we don't know R2 yet. What is L? Wait. As a point A. Yes, a point not an L. Okay, now tell me why this is well defined. What do you have? 给我看看。没有，那再想一想。
找英文的单词也是。
那你就用中文问呢？我可以用中文再讲一次，至少试着用中文讲。而且慢慢也习惯了，也会习惯的。你可以用中文问我，没事儿。先自己想一想。你知道这题是什么意思吗 ？OK。Do you know what it means to be well-defined? What do you think you need to show to have something well-defined? What do you have?
I don't know what that, like, number 2 kind of means.
The cap thingy?
Yeah.
Oh, that means intersection. So you have a one set. Okay, so this means intersection. So this means that I have one set A and one set B. In the overlap, this here is called A intersected with B. Okay? So it means if I draw this thing, it's actually quite easy. I have a point A, a point B, and I have a ray starting from A going out to infinity through B. But then I have another ray starting at B going in the direction of A, right? Now the intersections of where these two rays overlaps should be exactly the segment between A and B. That's what this here says. Okay, so if you draw it, it's quite easy, right? But the question is, how does this follow just from this? Okay, it's slightly more like clear, but now write it down properly. So the question is whether you have, I mean, it needs a little bit of experience, right? The others have, write math quite more often, but basically that's the idea. So the question is, why do you have that just from these things? Okay? Show me what you have.
是不是这个？
which I think this is a book one is this. For example, you have a plane P and L be a line.
Yes.
And for example, there's another line intersected.
Yes.
Which is intersected not empty set. And we know that by accident in incidence, they're exactly one. Because if they're not exactly one, and then, for example, let's say B and C. If they have another intersection point A prime, then A prime, these 2 points is not determined a line uniquely.
Yes.
So that it has absolutely only exactly 0 or 1 intersect point.
Yes, but now how do you define a half plane?
I'll do it later. And
写下来，帮我写下来一下。
for given point,
It's easier
A,
to talk about it.
for given point A in L prime, because we have defined this one. So for example, this is O, and then we consider the ray from ROA. And let the half plane P be the all element. For example, this one is C, such that there it is a line, L, and it contains A, and there exists a ray that contains A, and is intersected, and C is in the ray of the intersected. This and
Yeah, but how do you define all the points? Because for this point, it's also
because
exists
that's
a ray.
only a ray.
Yeah, but this point here has also a ray, right?
But it needs to just it needs to intersect at this in L prime in the ray of this.
Okay, but now it can be simpler. Claim that A is a half plane. What is this set? A, B.
点集。
But
We don't have
对啊
A, B
你
yet.
怎么老沉浸在以前的那个思路里？现在根本就没有平面直角这个东西。你怎么
We don't have A,
老
B
沉浸在
yet.
这个东西里？
We just have points. The points we don't have coordinates yet. 不能这样写。
对啊，这是
Yeah, exactly. So how to do that?
That's really fun. This part.
So the idea is, can you define it just without, I mean, I think it's too complicated to define it with rays. I think it's possible, but it's probably too complicated. Try it with points only.
Okay.
Okay? And you need one line for sure, but try it with a point only.
Okay. Oh, I got it. Okay. I got it. That's right.
I'm thinking.
Yeah. Take your time. You know, you learn the most if you compute the result by yourself, no matter how long it takes. Right? It's not marathon. I mean, we're not in a competition who is the fastest, right? Who gets the result, that's more important. Okay? And the question is, who can stay with the problem longest and not who can do it the fastest. Okay?
Oh, okay, I got it.
Yeah?
Oh, cash. Okay, I got it. Let's consider the ray from the intersection point O, and so we claim that P is in the half plane, even only if there exists a line L prime, such that the point P is in the ray from this point, intersected point, and 2A is in this ray.
But then you need a point on the line, right?
Yes.
You don't necessarily. Why would you choose a point on the line to define half plane? It doesn't depend on point on the line.
What?
Right?
Okay.
So why would you need a point on the line to define a half plane? Half plane is something that's bounded by a line, but it doesn't depend on the points in there, right?
Yes, maybe.
So you should not choose a point to start with on the line.
Oh, so maybe a ray that doesn't go through A but doesn't touch
You
L.
mean, what do you need for half plane? What do you need?
So that is
You need- what do you-
so that is that L is a subset of that half plane or not?
No,
Okay, so that
normally it's not. So what do you need to define a half plane? What do you need? What to okay. So maybe the first thing you need to define is what is even a ray, right? We didn't define it yet. What are the points that makes a ray?
what's a ray?
Ray, again, you have 2 points, and it was a ray from A to B is the half line starting at A, which contains B. So all on this side is the ray. Okay? The question is how to write the point on this side down in terms of a set. Okay? So write down a set which contains all the points C in my plane, right? Satisfy, and that should be my ray from A to B. And if you like, you put the arrow here to be clear that it's from A to B. So what are the points? First of all, you have this point, right? And then you have these points. How to specify these points? We have the line, right? AB defines the line by this one. We have the line already. We just need the right side of the thing. Okay? So you need to first write down what array even means. Okay? Do you have it?
Yeah.
Wait a second.
that you write P in this one, even only if there exists a ray that it doesn't touch L, but it intersects with A, and that's the point.
Well, it P, and then you should do the ray so that, well, go from P to A.
Well, like this, for example, this is the L, right? And that's A.
Yes. Now you want to have a P.
Yes, you want to have a P in it. Even only if there exists a ray. And
From where to where?
There exists a ray such that A is in the ray and P is in the ray, but the ray doesn't touch L.
Yeah, but the ray, for the ray, you need to have a direction. So from where to where? From A to
But
P.
actually, you don't really. But actually, you don't need actually the direction because the,
so maybe the ray is in the wrong.
Because ray doesn't intersect with L, so that's and the position and the direction is exactly.
Yeah, but how do you specify now the direction? Because the rays have directions, okay? So the ray has direction. So whether the ray goes from A to P or the ray goes from P to A is a huge difference.
You can just let ray equals RAP, and so that
in your picture, yes.
And so that P.
But then if your point is here, then the ray from A to P intersect L, right?
Yes, but
that's still on the same half plane.
But actually, they also exist because you can just choose this one from P to A.
Well, if you have it on here,
but
you can.
There
are no what?
There are no rays, so that it's not in our half plane because because it's just not.
So do you really need a ray? That's my question.
The segment.
Yeah, I think the segment would be enough. Exactly.
Yes,
right?
It's segment.
Because why is segment better? Because it has no directions. Yeah.
Yes, maybe.
And now the question is, when you define it, why is it well defined? Now you have okay. Now I tell you this is a good definition. Okay.
Okay.
If you replace by segment. Now the question is, why is it well defined? What does it even mean, well defined?
Okay.
It's a good one.
That means well defined. You mean well defined is every line bound exactly to half planes?
Yes.
Oh.
And if you have, if I have 2 points, B and B prime, then if I just change my A to B, so the half plane LA and half plane LB should be the same because B lies on the same side, right? It cannot suddenly change the other sets. So that will be well defined, right? So, any progress? What is these? Wait a sec, I cannot read.
It's okay to instead of our raise to our segment, but this definition is the same with this, and
no, it's not quite.
This is.
The question is the following, okay? You have H, L, A, right? You define your half plane with the A.
Okay.
Now you define your half plane with the B, with another point, and B is in that half plane, right?
Okay.
So now these 2 half planes should be the same, right?
Oh yes. So
but how to
prove it? Okay.
So that would be the idea. So do I have a ray now? What do you think? How do you think should this go? So how do should the definition go? So what do you think you need to use when you have arrays?
A and B.
Yes, you need A and B. And you see, if the array goes from A to B, what kind of set does it contain? So it has all the points between A and B, right? And that had the name. What was the name for that? The segment between A and B, right? And this was this AB bar. Okay, now how to describe those points on this side? So these are the points C, right? Right? How to describe this point?
Is it like in the middle of B and C?
So that the B is in the middle of A and C, right? Right? So these are the points on this side where B is in the middle. And if you have C prime here on the other side, then A is in the middle. So these are the differences. So how would you define now? Think about it. It's very hard to write this down. I think you might not have the experience of writing down the sets, right? So that's something. The others have already lots of practice in these, right? So what is how to write sets? Do you know? So normally it would start with a set sign. You would have the set. So now, right?
Yeah.
Okay, so this is my set. And the idea is I write down all the C's, the points, okay, that are on my line, because the ray is part of my line, right? And this symbol means satisfying some conditions, right? Okay? So now, what are the conditions it has to satisfy?
That there's one point in the middle.
Yes, the one point is in the middle of the other two. So this is B in the middle of the other two, right? That's this part of the line. Okay, and that other, or there's another set, which is this one, or C in C, not element, A, B. Okay, so this would be the ray from A to B.
A, B.
For the elements of points that lies in between the segment, so the ray consists of the segment, right, together with the points on the other side, these element A, B. Sorry, I'm destroying your notes. For which B in A, C, right? So either it's in the segment, or that means it's a union. This is a union sign. So we had intersection there, and the union. So in the middle here, that's intersection, and the union would be all of it together. Okay, so this is the union sign. Now, if you have union, either the line consists of two separate segments, in a sense, right? The one between A and B, which is here, and going from B further to infinity, which is this one. All the C's for which B lies in the middle between A and C, right? All these points on this side. So now this together is my ray. These two parts together. Yes, all this. So it's the same. This set here is the same as this one. The points. Oh, can I have another pen? Something that you can erase again, maybe?
You want me to erase this?
No, something that can point. It's kind of a pointer-ish thingy. Yeah, maybe. Is that a pencil? Perfect. So all the points here. And all the points there. So the points here, I can call C if I want as well, right? Either C lies here or the C lies there. So C either satisfies is in AB or C satisfies this condition. Yeah? So either this is this condition.
Isn't this like, isn't B in the middle of the two?
Yes.
Okay.
That's exactly this condition here.
Yeah.
Right? This is what is this part, this part. This part, because it's or, here. So this is the same thing. I'm just writing it in one bracket or in two brackets. Okay? Now with the union sign, because either it's on the left-hand side or in the right-hand side. Both together is with the union sign, or I just write it into one bracket. And then it's contained in everything. Okay? Is it better? Okay. So it is very difficult at the beginning to learn the language, but that's the first part. It's far more difficult for you than for the others because they know the language already. They have it for a couple of years now. So, but the idea is really this one. So the overlap of these two lines is actually A, B. Okay? Yeah. Okay. Now the question is, what is a half plane? Now that we have the rays, what is a half plane? You can write it almost exactly like this. Okay? In a very similar way. Let me see what the others have. But it's far better to solve these things by yourself. But the problem is the others, since they don't know the language, how to write it, once they have the idea, they can write it down. But while when you have the idea, you still lack the language to write it down. So it's far more difficult. Okay. Now think about how would you define half plane? Just add in the drawing maybe first. Okay.
Is it like half a plane or?
Yes. So the idea is you have some line, and all the point on one side of the line would be the half plane. So you need to specify half plane. You need another point. A. Okay. So what is the difference between a point here, which lies in my half plane, and a point here? What would be the difference?
One's on the plane, like in the plane, and one's not.
Exactly, but if you want to draw something, how do you specify or differentiate between these points and these points with respect to the line, right? It's on the opposite side of the line.
Would that be negative or?
Yeah, but how to write it with these things, with in between some segment, some rays, some points, right?
Wait, and I have another question. Like,
yes.
What's path?
Oh, that was this axiom which said, when I had a triangle, 3 points, and a line, right? Either this looks like this, or the line crosses one of the edges. But then the Pasch theorem says it has to cross one other edge as well, which is clear, right? If you draw it.
Yeah.
So our plane is really like this, how we draw. When it enters the triangle, it has to exit the triangle. And that's why it has intersection with the other edge. Okay? The line could look like this. So it has one inside intersection here, one intersection there.
Yeah.
Okay? That's Pasch theorem. Okay. Any progress? Okay. Good. Let's pause 5 minutes. Someone will press a break. 5-minute break, and then we talk about the results. Okay. Solutions. 等一下，第一个难道有？等一会儿。Do you have？ 你有吗？第一个问题。I thought。
第一个问题来听着。
第一个问题没听啊？好吧，那。随便这吧。
There are four points. And we can then prove it was proper for this three
OK，
这三个公理。
都可以。axiom 中文叫啥？公理。好的。OK，good。还有一个 Mia, you have the second solution, right? Another solution. Yes, just write it down. Okay, what I like about this one is that it's a tetrahedron, right? And that means something three-dimensional can be.
But actually, these two are isomorphism.
Yeah, sure, but it's fine, of course. What I like about this one is because you can draw it this way, okay? And it basically says a plane is not a plane. It can also be something three-dimensional, right? Which is nice.
And the second one?
Second one, okay. Anyone else?
Not.
Okay.
P is my plane.
Yes.
One and like that.
Mm-hmm. Can you explain the symbols? I think Mia doesn't know the symbols. Can you explain the symbols?
That means there's two kinds of solution. Well, there's two kinds of things. One is B in AC or C in AB, and while C in AB or A in BC.
This is or, this is and. That's all. Yeah, it's like intersection and union. It's just with sharp. It means or and.
Yes, and by
And just shorter to write.
Four kind of possibilities, and by this one, by this one, all the axioms. The only case is that C in AB and C in AB.
Yeah.
Like this and this, AB.
Yes. Because of which one again? Because which axiom? Third. Yes. Okay. Because you cannot have this one and which one? This one. At the same time. Okay. Good. The third one. Let me just erase this first. Okay, a half plane.
Half plane that that has L as its bound and contains A.
Yes. Equals left equal.
Oh, no.
Otherwise, it's not containing A. Now, okay, when you have this.
That means A and B is on the same side of L.
prove that HLA, if B is in HLA, then HLB
We're
equals
going to
HLA.
prove this
Yes.
soon.
Now compatibility.
Well,
Defined.
well definition.
Well defined.
It's called well-defined. It's a verb. Yeah. Defined. Yes. Perfect.
Well defined.
Mm-hmm.
Let L be a line. Let L be a line. By axiom I1, A not in L. By I3,
Mm-hmm.
I3. Then HLA is C such that AC and L, the intersection of AC and L is empty.
Okay. This is the empty set sign. You know. Okay.
Empty. And so A is in HLA by row 2 and row 3.
Mm-hmm. Okay.
By row 2A, the segment AA is A and the intersection of L and A is empty.
Mm-hmm.
So A is in HLA.
Mm-hmm.
Let BC is in HLA.
Mm-hmm.
By row 4, HLA is non-empty.
Mm-hmm.
Yes. Then BA, segment BA, the intersection of the segment DA and L and the intersection of CA and L is empty.
Mm-hmm.
All empty. So the intersection of BC and L is empty. By axiom set to axiom 4.
Why?
Details?
Mm-hmm.
Okay.
Draw a picture.
If BC, if the intersection of BC, 7 BC and L is not empty, then
Mm-hmm.
then by Pash, or
Yes. Mm-hmm. Okay. Good.
a contradiction.
Perfect. Can I just draw a picture for the others?
Okay.
Because it's easier to draw the picture.
L, A, B, C.
Yes. Exactly. If C would be on the other side, what happens?
If C is on the other side, then C will be not an HLA.
Yes. But
No.
what will happen then? Well,
If BC, if the intersection of BC and L is not empty, that is, if C is not in HLB, then bypass. AB or BC will intersect with L.
yes.
So, a contradiction.
So the idea is the following. Let me just put it. So the idea of this is the following, okay? Very good. Yeah? Basically, that's it.
Yeah.
Oh, but let me just rephrase a little bit, okay? When you have a line, you can have an A here. And what this says is basically you have all the points on the one side, okay? Which means this has no intersection with L, okay? Okay, perfect. So when you take this point or this point and L and take the half plane, it's still the same half plane, okay? But now if I have C on the other side, okay, then A lies on the opposite side of C. And if B also lies in the opposite side of C, then B lies on the same side of A, which basically means if I have minus and minus, it's a plus again. That means I can only have two sides. Either it's on the same side or it's on the opposite side. Because if I have 2 times the opposite side, it will be on the same side again. Okay? So this gives me that there's exactly 2 planes and not more half planes. I mean, you have half, as in the name, you cannot have 3 half planes. Yeah?
Half.
Yes. Okay, perfect. So now what we have are 2 sets of axioms. One is incidence, one is order. Okay, now what we have is a ruler. What is, in Greek construction, what do we still need? Anyone knows? We have now a ruler to work with in geometry. What is what you learned in school, in real school? Yes, compass, the compass. Exactly. So we need axioms on the compass. Okay, so that's the third one. Let me just write down what those are, and then let's see what we can do with the compass. Okay. The third one. This is called congruence. So the first one says, when I have a segment, I have another point, so I have some segment here. I have another point, A prime, and the line A prime. So some line here. Okay? Then I can define on each side of a point, A prime from my line, a point, B prime, if I define this side for this side, such that AB is congruent, or I write this way, to A prime, B prime. Okay? In normal words, it just means this one has the same length as this one. Okay? So for any segment I have, any other point, and any other line through that point, I can define what it means to have the same distance AB and A prime B prime. Okay? So this, you can think about it, how to define a circle. So that's basically the axiom for the compass. Okay? Then there's a lot of bunch of compatibility thingies, yeah, which is less interesting. So if my segments, these two are equal and lengthwise, and these two are equal at B, then also the original one and these two dotted one are equal. It's just some type of compatibility, okay? And moreover, if I have A, B, C, and another set of 3 points with a different line, A prime, B prime, and C prime, and I have that this is congruent to this one, the second is congruent to this one, then the whole, as a whole, they are equal. Yeah, and okay. So these are, so this is the important one for the circle. These two are just compatibility, that they fit together, okay? In Chinese? No? It's good? Now we need angles. So these are segments. Angles. So till now we have nothing about angles, right? What is an angle, first of all? 2 rays gives an angle, exactly. That's an angle. Okay, let me call it alpha. Okay. Okay, 2 rays give me an angle. The ray from A to B and the ray from A to B prime. Okay, but now when is 2 angles congruent? The axiom says the following. If you give me A prime and B, let me call it C. Okay, B prime, this would give me an L prime. Then there exists a unique G prime such that these 2 angles are congruent. Okay. And then again, I have an angle given by L and G is congruent to L prime G prime. Compatibility, not that interesting. And the 6th one is basically triangles. Namely, if I have a triangle ABC, and I know this side and this side are the same length, this side and this side is the same length, and this angle and this angle is congruent, then also this angle and this angle must be congruent. Okay? Well, if you change notations, it also means that this and this is congruent. Yeah? That's all for congruence. Now, couple of things. Now you have what you have. First, you have a ruler. Second, you can mark kind of distances on your ruler. Okay? You can remember one distance. You have 1. Okay? If you have 2 points, then you have the distance between these 2 points. You have 1. And second, you have a compass. Why? So maybe you think about it, how to define a circle. Moreover, if I take some fixed A, yeah, and B, such that I have a C on the right between A and B with AB is congruent to AC. So basically it says A, B, and on that ray there's a C, so that this length here is the same as this length, then B is equal to C. Okay? So on each side, I have only 1 point of a given distance from A. And how to define minus B. Okay? So let me just say one thing, okay? What we have now, when we have 2 points, is the distance, A, B, that's 1. Okay, if you introduce integers, then you have suddenly 1. AA, you can say it's 0. The idea is from here, we can now define minus 1 to get the integers. Okay? And we can also get a half the distance. So that you can think about how to do it. Length of that. Okay? Yeah, 对，先怎么样子定义这个圆圈？OK， 差不多。
就这个是给定的，就是
B prime. But where are the lines? So how do you get? How do you get B prime? Why does it exist?
Actually, it really exists because
Yeah, wait, it's not written here. That's what I'm saying.
written 是
这没有写. Where are the lines? You need for.
You mean I need a plane to?
Yeah, you cannot. So, no, you need a line. So if you want to use here, then you need a line because you need an A prime first, some other points, and then a line. And then you can define this. You cannot do it without a line.
Oh, you mean AB is the segment of the line, maybe?
AB is just a segment.
就是你设了一个思考的颜色。
对。
你设了一个思考。
AB 是你有2个点，2个点定义一个直线。你还有另外一个点，然后你先需要一个直线通过这个点的，然后你才能有这个。要不然就没有。Okay. So basically it's correct. 那差不多是对的，可是你现在还得不到这个 B prime， 因为你没有点儿，没有这个 line。你那个
can't just draw a line randomly.
Yes, of course. You can take all the lines, sure. But then you still need that to do in the definition. That's
Why
all.
would they define a set of lines in the
Yes.
game?
You don't have paper? Wait a sec. Here's paper, right? Here. What is that?
对，还在想，
想什么？
感觉比较奇怪，感觉比较奇怪。
对啊，因为是从零开始的。
我都想尝试。
是的。哇，抱歉。放到后面去啊。Let me see.
Maybe P1. Okay.
Okay. The P is the lines in the plane. What is this?
L1, L2, it is.
Okay. It's a
end of
segment. What is?
L8.
Is it a L or H?
L1.
L1. Okay, good.
These points on L2 have.
What is this?
It is a segment, I think.
Plane is this way.
Okay. So P1, P prime, it is like a segment.
Yeah, but then it has no center, right? Where's the center of your circle? Oh, and a circle has a center.
Oh.
And
we claim that.
where's the center? So you need two things, right? So you need a radius, which is your AB, but it also needs a center, a midpoint, which is your midpoint. Where's your midpoint? Okay? So what would be the definition? What's your guess? Do you have one? You have one? A short one. I think your previous one might be better, but it's
Maybe okay.
just write down. Or you have to write a little larger, otherwise I cannot read it. A little bit, yeah.
Too
Too small, yes.
Okay, and
他们得可以读啊。
So is it okay? I mean the words, it is big or small?
可以读吗？你们可以。
Center of the circle. Center of the circle.
Just the center. Okay. 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 Dot. Period. Okay. 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 Let me just try. So, first of all, the problem is you only have one L2. You have only one line, yeah? So there exist how many points in this set? How many points do you have in this set? No. You have only one line, which is L2. It's fixed. So if you want to do this with P prime on L2, or
I think it is P1
oh, P1 is L2, P prime is what? What is P? What is P prime? Okay, but why do you need all this? Okay, so why do you need all this if you only want to write this?
Because I think I need to define what is AB, or AB isn't fixed and it is.
So if you want to define AB, the segment, you only need A and B.
Yeah.
No, nothing of this. All this is not necessary. So actually this can go, yeah? So if you want to write it this way, what you need is such that exists a line through P1 and P prime, right? That's all. So the circle consists of all the points with distance to a given P1, AB, such that I have really a line through these 2 points. I mean, otherwise it can, I mean, well, it's clear, right? But the problem is, otherwise you cannot use this one. I mean, you can say, well, there exists always a line by this one, and then you can have a line, and then you do this. But then but you cannot say that this distance is the same. You have to take an arbitrary point first, and then on that line you would do the other point, right? So that's just some. So let me just write it down. It's a set C such that circle A prime with center A prime is a set C of the point C such that AB equals A prime C with C lies on a line through A prime, in a sense. Huh? Or you can do that this way. Or, I think it's fine. If you really want to do that, you have to first find the point, then a line, and this. That would be the order of things. I mean, if you write down C already with this equality, then you already have 2 points, and of course there exists already a line. But you don't know, right? So this is somehow, well, probably it's fine. Okay. So now if you have a circle, you want, well, this part is maybe not needed, okay? Yes?
When we define the segment, so whether we define the center in the circle.
The center of the circle is A.
Oh.
Because A prime, here.
So we can use it in the after homework? Yes, maybe after homework. Homework.
Yes. So yeah. So basically, what you need now. I'm sorry. I think probably this is not needed. This line thingy. So the question is now, how to define 1 and minus 1, right? Okay. Let's. That's enough for today. It's almost 8.